All right. This is Algebra 2, Lecture 915 and 916, OS A2A21. Student will factor a difference of squares. Okay, a difference of squares is just one perfect square, like 16. And 16 is a perfect square because it's 4 times 4. Something being multiplied by itself is a perfect square. 16 minus 25 would be a difference of perfect squares. We're going to be looking at variables. Difference of squares using variables, sometimes constants. But here's the pattern we're going to be using to factor a difference of squares. That's our objective. We're going to factor. That means, remember, when we factor something, we're going to break it into two pieces such that if we multiply them together, we'll get what we started with. And differences of two perfect squares can be factored using this pattern. If you recognize and say, hey, this is a difference, subtracted means difference, of two perfect squares, that's something that's being multiplied by itself, a times a, b times b. You can always factor it using this pattern. Open up two sets of parentheses, take the square root of this one, whatever it is, in this case the square root of a squared would be a, put it here and here, the square root of this one here and here, take the square root of this one, in this case the square root of b squared would be b, we put it here and here, put a plus sign here, a minus sign there, and we're done. This is the pattern, the general case of the difference of squares. And we're going to apply this general case to 3 or 4 examples of differences of squares. And hopefully, when you see a difference of squares on the ACT, and you'll know how to factor it. It's pretty easy once you get the hang of it. Here we go. I'm going to follow this pattern. Factoring a difference of squares, I say, hey, that's a perfect square. That's 5x times 5x. And this is a perfect square, that's 3 times 3. So you have to recognize that it is a difference of two perfect squares. So the way I factor that is using this pattern right here. I'm going to open up two sets of parentheses. Whoops. I'm going to do that in red. Open up two sets of parentheses. Take the square root of this one, that's the thing that's being multiplied by itself. Well, that's 5x times 5x will give me 25x squared. So I took the square root of this one, put it here and here, take the square root of this one, the square root of 9, I put it here and here. We write a plus sign, write a minus sign, and we're done. Okay? That's factoring a difference of squares. You just have to recognize that it is a difference of squares, and that will work. I'm going to demonstrate that this is actually 25x squared by foiling it. This is the only time I'll do that. I'm just going to demonstrate that it does give us 25x squared minus 9 if I multiply these two together. Here we go. I'm going to FOIL these. 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. Then I'm going to take this positive 3 and distribute it. This gives me positive 15x. And 3 times negative 3 is negative 9. When I go and combine my like terms, I see that they're exact opposites. If one's positive and one's negative, I subtract. 15x minus 15x is 0, so that disappears. And I'm left with 25x squared minus 9. Because these canceled each other out, they turned into 0. Notice that's what I started with. What I just did was I demonstrated that if I use the difference of squares pattern to factor it, that's this right up here, I applied it to this situation. If I multiply these two together using FOIL, we will indeed get what we started with. So these are the factors of this perfect difference of perfect squares. All right, I'm not going to ask you to do that. I just wanted you to see that these are actually factors of this. If you multiply these together, you'll get that. Okay? So this right here is the answer we'll be looking for in a multiple choice scenario. Now look at this one and say, okay, this is a perfect square. That's m times m. This is 2 times 2. So this is a difference of two perfect squares. So I'm going to use the pattern. The square root of m squared. Well, what's being multiplied by itself? M. I put that here and here. The square root of 4. What's being multiplied by itself here? 2. Put that here and here. follow the pattern. Make one positive, make the other negative. And it doesn't matter which one comes first. You could make this one negative and this one positive. I just like to go plus minus because that's how I've always done it. You could write it like this, if you wanted to. But I'd write it like this, but if you write it like this on your scratch paper and you see this in your multiple choice setting, that's fine. Both of these are correct. Okay. And this could be 5x minus 3 times the quantity 5x plus 3. You could switch these. Just like 2 and 3. 2 times 3 is 6, or 3 times 2 is 6. Doesn't matter about the order. Order of our factors does not matter. Looks like I erased my 1. Okay, I've got a difference of 2 perfect squares. That's 4m times 4m. And 1 is a perfect square because 1 times 1 is 1. Here we go. I'm going to use that pattern. Going to factor it. Open up 2 sets of parentheses. The square root of 16m squared is 4m because 4m times 4m is 16m squared. The square root of 1 is 1 because 1 times 1 is 1. So I'm going to put that, the square root of this one here and here, make one positive, make one negative. And again, this is the correct answer. You would look for this. It could be written like this. If you were in a multiple choice, they might write it like this. The order of the factors, we can put this whole factors after this one. The order of the factors doesn't matter. As long as you have both of those factors multiplied together, you're good. And here's one. Now we've been talking about a difference of squares. That was in our factor, a difference of squares. Remember, the word difference means subtracting. We're going to be subtracting a difference of 2 perfect squares. A difference of 2 perfect squares. Difference of 2 perfect squares. A difference of 2 perfect squares. This is not a difference of 2 perfect squares. That's a sum of 2 perfect squares. A sum of 2 perfect squares cannot be factored. If you see that, just say cannot be factored. If you had something like 9x squared plus 81, you can say, well, I see both of these have a factor of 9 in there. And so you can say, well, I'm going to write down the 9 and then term by term divide it out and say, well, 9x squared divided by 9 is x squared plus 81 divided by 9 is 9, factoring out the common factor of 9. And I'm left with a sum of 2 squares here. Even though these are perfect squares and we have a sum of 2 squares, we can factor out a common term, but this resultant sum of 2 squares will not factor. A sum of 2 squares, if it has no common factor, will not factor. A difference of squares will. A sum will not. Cannot be factored. Okay? So there we go. Difference of squares. You can do this.